Good afternoon, esteemed professor and ladies and gentlemen. Today I will present our works entitled "A Design of Secure Supply Chain Management System with Blockchain Technology." First of all, let me introduce myself. My name is Alexander Johan. So this is a brief outline for my presentation today. And then there are two reasons why we want to do this research, why we want to research about the supply chain management system, and then why we want to develop this blockchain-based supply chain management system. So because we noticed that there's increased complexity in supply chain management models, especially a low data transparency involved in the supply chains. So this is caused by most of the large enterprise tend to build their own supply chain network and also store their own data by themselves. And then some organizations even they don't have full integrations of the supply chains. So we know that there are several entities, several parties involved in the supply chain, such as the manufacturers and then the distributors, the retailers. So most of these organizations, most of these entities in the supply chains, they do not have a full integration of their system. So usually each of the entities, they will need to store the data in their own system, and then the other party, they cannot share some of the other or important data that is required in the whole supply chain. And then the traditional supply chain management model uses centralized third-party participations. So for examples, digital versions of supply chain management system, IT-based supply chain management system that is well known is using EPC information system or electronic product code information system. However, in order to use this system, there is one mandatory requirement, that is the existence of a centralized third party that will store and manage all the supply chain data, all the event in the supply chain data. So therefore, we think that this field is worth to research, and these are our contributions. So we combine blockchain technology, which use the decentralized architecture, with QR code technology to build a secure supply chain management system. And based on our designs, a secure blockchain-based supply chain management system is proposed. In our proposed system, we use two channels to verify the supply chain data, two channels of information. So the first channel is the digital channel in the digital form, and then the second channel is using the physical format or physical form. And then our proposed solutions are proved to be more cost-effective and more secure system compared to the traditional RFID-based supply chain management system. We did several research previously. We searched through on the development of the supply chain management system, and then we found out that actually most of the existing supply chain system, they use a traditional IT-based system called EPCIS, and also combined with RFID technology. And then there are also several literatures that also try to create a blockchain-based supply chain management system. So in these presentations, I show several of them. So first of all, here the Rishberg and Mr. Becky, so they use the traditional model of the supply chain system using the EPCIS and also RFID technology, and then Tian and Mondal et al. They propose a blockchain-based supply chain management system. However, still their proposed system, they use the RFID technology, and then there are several noticeable weaknesses in this the existing system. So some of the system they cannot prevent the counterfeit product. So even counterfeit product can still be verified as a legitimate product, and also some of the system they might provide traceability, and some of them only partial traceability functionality. And then they also don't have an anti-cloning system, and also they don't protect some of them do not protect the data privacy of the supply chain data stored in the system. And then one of the most important reason is that the implementation costs in the existing system, they are more higher compared to our proposed solutions, because when they use the RFID technology, then they need to prepare for the RFID tag, and then for the recipients, they also need to have this kind of RFID reader to be able to read the data from this RFID tag. Based on our research, we conclude that there are 4 entity groups that are commonly involved in supply chain. So the first one is the vendor layers, or the manufacturer of the products. And then next, the downline layer will be the wholesaler or the distributor layers. And afterward, it will be the retailer layer. And then from the retailer, the retailer will send and then sell all the products to the consumer or the end user. Based on this common distribution layer diagram of supply chains, so we try to recreate a complex supply chain network architecture. So we acknowledge that the vendor, they might have multiple suppliers, so in order to create their own product. So here in the vendor layer, there might be a multiple vendor that will interact in the system, and then this vendor will sell and ship the product, their manufactured product, to their own distribution channel, or through the wholesaler or their distributors. And then for one wholesalers or distributors, they might have another downstream distribution channel, such as another distributors in some of the regions. So for example, this is the distributor in the level of a country, and then next it will be a distributor in terms of the regions or of some kind of a province. And then from this distributors, the product might be will also be sold to the retailers, and then the retailer then will sell the product to the consumers. There are 6 assumptions in our proposed blockchain-based supply chain management system. So the first one, a vendor is an entity that creates their own products, or modifies or combines products from other vendors, and then sells the products to the distribution channel. And then second, a shipment smart contract must be created each time a vendor wants to distribute their products to other entities. And then the shipment smart contracts can only be created by a vendors, while for the distributors or wholesalers and also the retailers, every time they want to ship the products to their downstream layer, or then they need to utilize the shipment smart contract that has been created by their corresponding vendor, by the corresponding vendor of a specific product. And therefore, each product will have a unique QR code. So this QR code will be used to prevent the counterfeit product in our system, in our proposed model. and then sender and receiver have an off-chain shipment invoice for each shipment, and then each of the involved entities has their own private public key pairs and also wallet address in the blockchain network. Otherwise, they will not be able to join the blockchain network, and then they will not be able to do the transactions to communicate with their peers. So this is the proposed our proposed network architecture. So there are basically 4 entity groups. The first group will be the vendors group, and then wholesaler or distributors group. The third one will be the retailers group, and then the last one will be the consumers. So the vendors, every time the vendor wants to ship their products, then they need to send the shipment data through their own clients, to client machines, to their blockchain node. So this blockchain node will be used to communicate with the other peers in sending the transaction data, sending the shipment data throughout the blockchain network. So this data will be propagated from one node, from one peer to another peers. And then the similar things also happen for the wholesaler and retailer. So wholesaler and retailer, for wholesaler, so every time a distributor or wholesaler wants to ship the product, then they will also need to store the shipment data into the blockchain. But the difference with the vendor here, the wholesaler, they don't need to create the shipment smart contract. They just need to reutilize the shipment smart contract that has been created previously by a specific vendor. And then the retailer, so for the retailer, so mostly the retailer will also need to interact with the blockchain network, especially in terms of verifying the shipment data. And then for the consumers, so these consumers, they can interact with the blockchain network to trace the originality of the product that they purchased, that they have purchased previously. So this is the flow of our proposed blockchain-based supply chain management system. So this flow will be executed, will be carried on every time a shipment will be performed between 2 parties. So in this, for simplicity, the 2 parties, the first party will be called as a sender, and then the second party will be known as recipients. And then for sender and recipients, the roles can be interchangeably between the vendor to another vendor, from vendor to distributors or wholesalers, and then from wholesaler or a distributor to another distributor or wholesaler, and then from one distributor or wholesaler to retailer. And then for the retailers, as I've mentioned previously, the role for the retailer in our system here is only to verify the data, the product that it received from the upstream distributor. Okay, so first of all, every time a sender wants to create a shipment, so let's say a vendor or a manufacturer, they want to ship a product to its downstream layer, to its distributor or wholesaler, then the sender must send a shipment contract creation request to its node, to its full node in the blockchain network. Then in the sender node will create the shipment smart contract. So of course the shipment smart contract will store the vendor's ID, for example, the vendor's ID, and also it will have the smart contract address. Then after a shipment smart contract has been created, this shipment smart contract, the smart contract address will be returned back to the sender's client, and then the sender's client later on can distribute the smart contract address to its own, to its potential or to its distribution channel. For example, from the vendors, it can send its smart contract address to another vendors that will receive the, the product created by this manufacturer. For example, from manufacturer A, the manufacturer A will send its own smart contract to the manufacturer B. And then, for example, if the sender is the manufacturer and then the recipient is the distributor, so every time this sender wants to ship the product, then it can just send the shipment smart contract, the address of the shipment smart contract to the recipient client along with the shipment data later on, because the shipment smart contract has been created in advance. So afterward, the sender will input all the shipment data and create the security tokens. So these security tokens will be divided into two parts. The first part will be sent over the digital channel, and then the second part will be sent over the physical channel. And then this shipment data along with this security token will be sent to the sender node to be stored into the shipment smart contract. And then once the shipment data has been stored, a feedback will be sent back to the sender. So of course, every time a data are going to be stored in the blockchain, it needs to be verified by the other peer network. So this is the role that will be taken by the other vendors or wholesalers, distributors or retailers to verify all the transaction, all the shipment transactions created in the blockchain network. And then after that, the senders will send the shipment QR code in the physical form along with the physical product and also the shipment invoice to the recipients. So this is the flow to verify shipments. So once the recipient receives the shipment QR code and the shipment invoice, then the recipient will decrypt the shipment QR code and extract the shipment data. Then it will send a request for a specific for the corresponding shipment smart contract. Then the recipient nodes will retrieve the shipment smart contract and then send the smart contract data back to the recipient client. And then the recipient then will decrypt the security token from the shipment smart contract and then combine the physical and digital security tokens into one full access token. Then this recipient later on can use these access tokens to verify the received product from the senders. Well, for any users, especially for the customers, so every time a customer wants to check the originality of their product, so the users can use this product tracing, the app or distributed app. So to use this tracing capability, then the users just need to send the product ID and also the last shipment ID. Then this app will trace the product, read the data that are stored in the blockchain ledger, and then tracing the product until it reaches to the corresponding vendor. If the trace data can be traced back to one legitimate vendor, then it means that the product should be an original product, not a counterfeit one. So we also implement a prototype based on our design. So this is the specification of virtual machines in which we run our blockchain network. So in the virtual machines, so we said that the virtual machine to have 2 CPU cores, and then it has 10 GB RAMs, and then for a virtual machine it will run 5 full nodes. So these 5 full nodes, it represent one node represent for the vendors. Sorry, 2 nodes represent for the vendors, and 2 nodes representing the wholesaler or the distributor, and 1 node representing the retailer. And then we use Quorum blockchain network. So this is the differences why we use Quorum. We use this because Quorum is offer more flexibility instead of the Ethereum, and then based on our experiments that our proposed model it support more features instead of compared to the existing system, such as it has the anti-counterfeit features, and then it also has traceability features and the anti-data cloning, the shipment data cloning, right? And also we protect the data privacy, especially the sensitive data in the supply chain. So not all parties can read the data. So only the legitimate entity that has the access key can read the supply chain data. And also the implementation cost, since we are using the QR code instead of RFID, then the implementation cost for our solution is comparatively low compared to the other solutions. So this is the conclusions. So our proposed model creates a secure blockchain-based supply chain management system using QR code, and the blockchain technology is utilized to protect confidential data while allowing the data to be shared among peers in the blockchain networks, and then the data stored in the blockchain ledger are traceable, and the QR code technology is easier and relatively cheaper to implement compared to the RFID technology. And then the two-channel verification methods in the proposed blockchain-based supply chain management system secure the data digitally and physically. So the sensitive data stored in the blockchain ledger are encrypted and can only be accessed by authorized user, and a part of access key to access this sensitive data stored in the blockchain ledger stored inside the QR code in the physical form, and then this physical QR code will be sent along with the shipment invoice and also with the physical products. So these are lists of the literature that we use in our research. So we welcome any questions. So the questions can be addressed to my email here in johan@staff.ubaya.ac.id. And thank you for your attention.
Good morning, everybody. I am Susana Limanto from University of Surabaya. This time, I would like to present our research about School Finder, an intelligent recommendation system for elementary school selection. The background of our research are one of the national goals of the Indonesian is to develop the nation intellectual life. To achieve that goal, the Indonesian government announced a compulsory education program. Elementary school is a basic level of formal education required by the government of Republic of Indonesia for all citizens aged 7 years old. Elementary school age children enter the final state of physical development, motor, cognitive, socio-emotional, language, and religious moral to impact the thought process for the child's future behaviors. Meanwhile, children aged 6 to 7 years do not have the ability to make good judgment. Therefore, the parental involvement for choosing the best elementary school for their children is needed. Every parent usually has a lot of consideration in determining the best elementary school for their child. A questionnaire survey was conducted on 50 parents who currently have children attending kindergarten or elementary school. The results show that the criteria usually used by respondents to choose elementary school can be seen in the table beside. There were 7 main criteria used, namely facilities, academic, distance from home to school, extracurricular, course, type of school, and testimonial from other people. On the other hand, the number of elementary schools in a city can be many. For example, based on the data quoted from the Ministry of Education and Culture website in the city of Surabaya, there were 815 elementary schools, which were divided into 287 public elementary schools and 528 private elementary schools. The number of elementary schools in a city make this school compete with each other with their respective advantage to be the best. The number of criteria considered and the number of elementary schools with their respective advantages often make parents find it difficult to choose the best elementary school for their children. Many applications have been developed to help overcome the parent difficulties in choosing an elementary school. But many inputs that must be done make the application less attractive to use. In addition, the available elementary school options in the application are limited in number. To overcome that problem, a mobile application was created to assist parents in choosing the best elementary school according to the given criteria with minimal input and dynamic elementary school present. This mobile application was named School Finder. The recommendation is determined using the analytical hierarchy process method. The criteria used in the School Finder application were divided into two types. The first, criteria for the initial screening process, and the second, criteria for the main process. Criteria used for the initial screening process were the type of school and testimonial. Based on the type of school inputted, elementary schools that meet the criteria will be displayed. After that, user can select the elementary school that will be used in the main process. The hierarchy of the criteria that will be used in the main process can be seen in the figure beside. There were 5 criteria, namely facilities, academic, distance, extracurricular, and cost. Some criteria have sub-criteria itself. This is the main page of the School Finder application. School Finder application provides 3 main features. The first, elementary school information. The second, elementary school recommendation. And the third, application usage guideline. The second is the page for parents to select the criteria to be used. This is the page where the School Finder application will display elementary school recommendation according to the criteria determined by parent in the order of the best. The accuracy of the School Finder application was assessed through internal testing and external testing. 4 different scenarios was used in the internal testing. This is the result of the internal test. In each scenario, a different combination of criteria and school was used. From the result of internal testing, the experts state that the recommendation from the School Finder application were able to accommodate all the criteria given the parent according to the existing school condition with an accuracy of 99%. The research showed that the school finder application was worth to be used. The external test was conducted on 30 parents who will send their children to the elementary school level. The first time, an external test was carried by demonstrating the features and working of the school finder application. After that, respondents were allowed to try the school finder application independently. After trying the school finder application, its respondent was asked to fill out a questionnaire. Based on the questionnaire data, the following data were obtained. 96% of respondents agree that the criteria provided by school finder application were in accordance with the criteria that parents will use to choose an elementary school for their children. 97% of respondents agree that the school finder application was very helpful and made it easier for parents to choose elementary school according to their parent wishes. And 97% of respondents agree that application could provide complete information about school. Regarding the design myth, 100% of respondents agree that the user interface design was clear and easy to understand. And 97% of respondents agree that the application was easy to use. At the end, we can conclude that the school finder application assists parents in choosing the best elementary school based on the criteria decided by the parent. And for suggestion in the future research or what an achievement achieved by school can be used as criteria in school selection. Thank you.
Hello everyone, thank you for joining with us today as we want to present our study or our research for the InCITE 2021. We have already conducted a study of the online attendance system models for educational institutions. Please let us introduce ourselves. We are a team of two. The first researcher is Mr. Andre and myself, Marcelinus Ferdinand Sotiadi, or Ferdi for short. We are both from the Department of Informatics, the Faculty of Engineering, from the University of Surabaya or UBAYA, from Surabaya, East Java, Indonesia. Yeah. We really thank you for the opportunity today to be able to present our findings for this study. So, as we all may have known, we are in the COVID-19 pandemic situation for now, for at least 1.5 years. This forces the educational system to adapt into distance learning methods, or we know here as LFH, learning from home. And in Indonesia, the student attendance is actually mandatory as to test the attendance of students, whether or not they actually follow the courses from its classes. As we studied this educational system attendance systems, which has already been explored before, we found out that the online attendances techniques can be categorized into two authentication types. The first one is the biometric based and the second one is the non-biometric based authentication. So we explored previous studies. We have found about the biometric based authentication that uses a voice recognition. So voice recognition is usually used to understand what the human speaks For example, like generating a closed caption for what I'm speaking right now, but it can also be used to identify who is speaking. This research has already been conducted by Shah et al. So, for example, my voice is what you hear right now, but obviously you have your own voice. So our voice can be used to identify ourselves. Yeah, but the noisy environments can lower the accuracy of the voice recognition, so it may uh, give us the result of false positive or maybe false negatives, yeah, by Nityanthana et al. So, and also with the COVID-19 restrictions in all over the place around the world, voice recognition system should be able to recognize voices even when we wear masks. Yeah, when we talk using mask, then our voice may be a little bit muffled. So it is mandatory for the voice recognition system to be able to still recognize us based on the recorded voices. And to enforce physical distancing for safety measures, then centralized voice recognition stations must be set up properly with all the health regulations considered. Yeah, for example, for the voice recognition stations must not create queues or gather large amount of people to do the voice recognition. Another biometric attendance system is by using fingerprints. So fingerprints is usually unique per person, so it can be used to identify someone. There are a couple of studies, which are plenty of them, regarding fingerprint attendance systems with great accuracies so far. For example, by Senel et al., Mittal et al., and Kamaraju et al. To minimize the risk of spreading COVID-19, because we need to use a centralized fingerprint stations, a touchless fingerprint system may be examined, which uses a camera instead of a dedicated fingerprint sensors, as we usually use today. Android systems can also be developed as alternatives in fingerprint-based attendance systems, because as we know, there are more and more Android smartphones that have the fingerprint sensor embedded into the smartphone itself. So we can take advantage of this sensor to develop an Android attendance system. Another biometric-based authentication is by using a face recognition. There are also some studies based on the face recognition authentication systems. For example, face recognition with a real-time video processing by Yang et al. And then an Android-based attendance system using face recognition by Sunaryono et al. But we have some challenges regarding to the face recognition system, such as environmental conditions, like the lighting in the room can actually affect the accuracy of face recognition, and blurry or maybe out of focus camera can also affect the accuracy, as well as the students' facial accessories like glasses, and for now we are required to wear mask, so mask can also hinder with face recognition. Yeah, although there are some research either ongoing or already published about the face recognition by using masks. Yeah, so the face recognition can still recognize people even when they are wearing masks. Due to the COVID-19 health regulation, it is currently not advised to set up a face recognition booth for students to scan their face one by one, as still will create long queues or large number of people gathered within one space, and is against the physical distancing regulation. Yeah, one approach to overcome these limitations is maybe by using a real-time video processing. In the meantime, for the non-biometric based authentication system, we have explored using RFID and NFC as well. So in this kind of attendance system, students tap their student ID cards into an RFID reader. Then the system will record the student ID, which is already recorded on the student ID cards, and as well as time of reading as the data considered for the attendance. But these systems can easily be tricked, so students can bring along their friend's student card and they can tap into the student card. So the system will regard their friends as being attending the class, but in actuality, the friend may be elsewhere. There are NFC-based attendance systems where the students can either tap their student card or their smartphone instead. So there are some approaches regarding to how to identify the students for their attendance. However, we argue that both RFID and NFC attendance systems may still create a long queue for students to be able to tap their cards or smartphones. So again, this is not ideal during the COVID-19 pandemic era. So from the previous studies and observing our current situation with the COVID-19 pandemic situation, these circumstances raise the need for an online attendance system which focus on the user as the part of a design ecosystem. So we propose online attendance systems to overcome these limitations as well as to conform with COVID-19 health regulations as well. This user-centered driven approach has been standardized as a general solution for developing a reliable system. And the developed system must adhere to the good user interface, which eventually will deliver a good user experience for both students and lecturers as well. Our proposed model can also be used or adapted in online hybrids or even in hybrid settings where the students can attend either offline or online while still conforming with the COVID-19 health regulations such as physical distancing. In our system, we see that the biometric solutions don't seem to be suitable for the online attendance system, so we proposed models that uses a non-biometric based solution which requires internet connection as well. So we propose three models for our attendance system. The first one is the automatic QR attendance model, which will require zero lecturer involvement. And for this model, the system will generate a QR code for each student, which are unique. So students cannot exchange their QR code to the others. And the QR codes are shifting every 10 seconds or so. The second model is a manual QR attendance model. This model requires the involvement for the lecturers because they will need to open or close the class manually. And then the lecturer shows the shifting QR codes that the students must manually scan the QR for their attendance to be recorded to the system. The third model is the authenticator attendance model. This model requires no smartphone camera at all, but the students must use two devices, a smartphone and a laptop. So the students then enters a shifting authentication codes to record their attendance or their presence into the system. Let's take a look at each of the models in more depth. So the automatic QR model does not require lecture involvement at all. The lecture should be more focused on the learning process rather than doing manual attendance or the administration process of doing attendance. In this model, the QR codes will be changed periodically and the requirements to use both supporting apps and the web systems make it harder for cheaters to expose the system or conducting any proxy attendance. So the students must use the system by themselves to be able to attend the class or be considered as attending the class. The participant will need to sign into the web system and the system will automatically check for an ongoing schedule. If there is an ongoing schedule, ongoing class, then the system will periodically generate a unique QR code per participant and the QR code will change within a 10 seconds interval. The participant then use the supporting app to scan the QR code and it is validated back by the system. So the results will be triggered to the participant app with two possible results, whether they attend the class on time or they are late. So this is the prototype of a working model actually. At the website part, they can request for QR codes, which will be changed for 10 seconds. And we have also provided the instructions to do the attendance. They will need to open the QPass. QPass stands for QR-based attendance system, which is the name for our model here, and so on. If it is successful, then the attendance will be recorded. In the app part of the student's smartphone, they can take a look at any classes in progress, and they must request a QR code from the QPass website, and they must scan this QR code to be able to be recognized as attending the class. The first model, however, assumes that the class schedule policy is embraced or enforced as the general procedure. For example, in UBAYA, there is a policy of 15 minutes late attendance. After 15 minutes, then the students are regarded as not attending the class. So the lecturer does not have a control over the attendance time. It means that the participant can record their attendance as being late even after the class has been conducted. To prevent this, then we developed a second model. The second model embraces the manual action for the lecturers to actually open and close the class manually, allowing participants to attend the course. The lecturer must authenticate into the web system and then start the class as allocated by the schedule. The system will validate the timestamp, current timestamp, and periodically generates a new unique QR code every 10 seconds. The lecturer can then display the QR code on the screen through any online conference systems such as Zoom, Google Meet, or Microsoft Teams. Every other participants, students in this case, must scan the QR code shown by the lecturer using the supporting app. The system then receives the requested task, validates its code, and then returns the result as a feedback to the participant application. Here are some screenshots of the manual QR model. The first one is for the lecturer. This is the instructions for the lecturer to, after opening the class, then they must click this button, show QR, for the students to be able to scan with the supporting app. And in the second screenshot, we see here that some students have already attended the class, and the log time is actually recorded, and we can also override the attendance for each student in case that a student is actually comes to the class but forget to perform the attendance required. So we can switch from not attend to attend, and vice versa. We can also change the status of any students from attend to not attend. Yeah, so for example, maybe the student has already entered the class but is idle for the duration of the class, and he or she does not respond to the lecturer, then we can actually switch the status from attending to not attending. So in this case, the lecturers are free to enforce the attendance policy by themselves. The two previous models require the participants to use an application and a camera permission to scan a QR code. This may impose a problem because it really depends on the smartphone's camera hardware to actually record the attendance from the students. So if the smartphone camera is having a trouble, then the students cannot really record the attendance. Therefore, we develop a third model to overcome this problem. In this third model, we introduce a simpler attendance system without using any specific hardware, without needing access to a camera device, but it should be still reliable and prevent cheaters from proxy attendance. So this model uses the token-based password authentication to authenticate the user credentials. The participating students will authenticate themselves into the web system, and the system will validate the current ongoing class, enabling the attend button. To do so, the participant must enter the correct authenticator codes that are shown in the supporting app into the web system. These codes will be changed every 10 seconds and consist of 10 alphanumeric characters. The authenticator code is uniquely constructed for each individual students, so students cannot exchange their authenticator code. So the student must link the application with the system. Yeah, the student must be logged in into the application with the same credential as the web system. If the authenticator code is valid, then the attendance data is recorded for the student. Here are some screenshots of the third model. So in the application, it will show a class code here. In this prototype, we only use a 5-digit alphanumeric. It is a number for now. This code must be entered into the QBus website to record the attendance. And this code will be refreshed every 10 seconds. So we can summarize these three models into this table for the automatic QR, manual QR, and the authenticator-based model. About the lecturer involvement, only the manual QR system actually mandates the lecturer to actively involve themselves into the system by opening and closing the class manually. But for the participant involvement, all of the three systems mandates for participant involvement. The automatic QR requires the participant to scan the QR code. The manual is the same, and the authenticator, actually the students need to log in into the website and use the authenticator app as well. For using a camera hardware, only the authenticator does not use the camera because it is a token-based authentication. In the meantime, for the web platform and app platform, all of the models require both platforms as well. But for the web platform, the participant needs to use the web for automatic QR model and the authenticator model. For the manual QR, only the lecturer needs to use the web platform actively. In the meantime, for app platforms, they are required for every model here and only for the participants. So the lecturer does not need to use the app platform. For the implementation, we adapt the interaction design or IXD framework, which emphasizes the human factor when designing the interactive products and services. We choose to develop a native Android application for this time to validate our models heuristically, and based on the fact that Android smartphones are more widely used in Indonesia than the iOS smartphones. And additionally, the web-based system with multiple user access has been developed and designed to test out whether it fits our model's intended goals, which allows the multiple user access, the participant, administrator, and the lecturer, as well as managing master data and participant enrollment and other configurations, as well as for the lecturers can use the web systems, open the class, and display QR codes to the participants in the manual QR code model. We follow the heuristic evaluation that evaluates 10 principles in user interface to provide a good user experience, the UX. The heuristic evaluation is conducted by 2 evaluators to improve the accuracy of the perception method during the assessment for our models. And we decide to set a value or weight for each principles, for each these 10 principles that shows the essential factors. So there are some principles. We have 10 principles to be tested, but we focuses on 2 principles, which is VS, visibility of system status principle. It is the most essential factor that we must consider during the designing and of these models. So we give them a quite large weight because the participants should be well informed regarding of the current time, currently attending status, and all other important stuff like the schedule of the currently ongoing classes. The second important principle is the MW principle, or the match between system and the real world. So this principle states that the developed model should be closely related to the previous experiences in the real world. In this case, it should be closely related to the participant experiences when the offline attendance systems were applied in their previous classes. So here are our evaluation results for the 10 principles. Here we have a VS and MW given the essential factors or weight of 0.2 and 0.05 respectively, as well as the other principles with their own weight. Here for the feasibility of system status, the positive findings, we get 3 positive findings. Yeah, we consider this as a good findings because we can provide a clearly visible status to the participants or the users. For the match between system and real world, or MW, there is actually no positive findings and negative findings as well, which means that our designed models closely resemble to the offline attendance experiences, but we don't have any improvement yet. So this is an opportunity to actually improve these models. Based on these findings, then we can conclude that the automatic and manual QR codes, both of them offer zero involvement for the lecturers to conduct the attendances. So the lecturers can focus on the way of teaching instead of doing some administrative work on recording the attendance for every student for each classes or courses they teach. The authenticator model, on the other hand, provides a control for the lecturers to start or dismiss the classes manually. So this will maintain the reliability and accuracy of the attendances. Because the lecturers can specifically control when to start the class and when to close or dismiss the class. So the attendance can only be recorded during this course of time. Nevertheless, all model goals are set to reduce administration difficulties during online courses. And working prototypes of the end products, as we have already demonstrated to you by some screenshots, they all follow the principles of heuristic usability evaluation as a guideline to develop good user experiences to the users. For a possible research in the future, we can suggest you some points here. Based only on this approach, we actually cannot derive the solid conclusion that this model supposedly can prevent participants from cheating or doing a proxy attendance. So further research should conduct more extensive empirical studies to gain a more detailed evaluation of each model's usage, usefulness, and feasibilities as well. And additionally, these models should be compared with other models that have the same principles and plans. In the meantime, more investigation should be carried out in more depth whether the model should be reliable enough in different configurations, different circumstances, different environments, and as well as enhance the system to prevent proxy attendances. So that's all of the presentation about our research in online attendances using a QR-based attendance system as well as token-based authentication models. We hope that our research can provide to universities or schools to be able to record the students' attendance during the online study or learn from home. As well as maybe these models can be also implemented in an offline settings after this pandemic has been eradicated. Should you have any questions, feel free to contact us at these emails, andre@staff.ubaya.ac.id or ferdi@staff.ubaya.ac.id. We will be more than happy to answer your questions. So that's all for today. Thank you for listening our presentation, and stay safe and stay healthy for everyone. Goodbye.
Well, good day, everyone. My name is Eliezer Tarigan. I am from University of Surabaya from the Center for Environmental and Renewable Energy Studies. And this opportunity, I am going to present my paper with title Simulation of Impact Azimuth Angle on Specific Energy Output of a Fixed Mounting Rooftop PV System in Jakarta, Indonesia. Thank you very much for your attention. And the outlines of my presentation will be background, methods, results, conclusion, and finally some recommendations. As a background, we know that energy mix national target of Indonesia in 2025 is 23% from energy demand will be supplied by renewable energy. This is optimistic target. So the only way to achieve the target is by promoting renewable with many aspects. One of renewable energy is solar energy. Solar energy in Indonesia has a benefit of the position, astronomical position of Indonesia around equator line. Solar energy is abundantly available. And one of the limitation of solar PV is it needs space for placing of the solar panel. So it needs normally free land to install the system. However, rooftop, as we know that one of the appropriate solution, because when we use roof as a place for placing PV panel and then no longer need free space. So rooftop is one of the solution for limitation of placing of PV panel, particularly for the urban area like Jakarta, as we do the simulation in this study. Yeah, again, that for placing in the real installation, we need to conduct the appropriate studies before implementation. So this is the background of this research. And rooftop is usually used for placing panels where free land or free space that very expensive, especially in the urban areas, as we already mentioned. So rooftop is one option. Rooftop PV panel usually connected to the grid. So there is no battery storage to lower cost, and it will export energy during daytime, and during nighttime the house where a PV panel is installed is import the electricity from the grid. So this system is already been regulated in this country, in Indonesia, under the government policy. So the owner of the house is possible to install the PV panel and export the energy, and it will be calculated, it will be recorded in the meter. What we call is export-import energy meter. So during daytime, as already mentioned, will be recorded and exported, and then during nighttime, it will be recorded energy imported, and last month, and the last day of the month, I mean, it will be calculated. If imported energy is higher than exported, and then will be the owner of the house will be paid the remain. If the exported is larger than imported, then the owner of the house will be accumulated his the energy difference to be used for next month. This is the roughly regulation. For detail of regulation, it's available in the number of 49 of Minister of Energy and Mineral year 2018, so it can be found there. Okay, so theoretically, solar energy or solar radiation comes to the panel is maximum when the cosine of the angle of incidence is maximum as well. So in this case, cos theta should be 1, so theta should be 0. Zero of the theta means the radiation is perpendicular come to the panel, and theta itself depends on the several angle, including angle of declination. This depends on the season of the month, and then theta, this is latitude. Beta is angle of tilt according measured from the horizontal, and gamma is azimuth angle, omega is hour angle. So all of these will change over time. So how to maximize is how to make the theta as much as possible. Cos theta, I mean cos theta would be closely 1 to get the maximum of solar radiation, to receive maximum radiation, and then to get the maximum energy as well to be converted by the panel system. So in these studies, we will talk about azimuth angle itself. So we make a variation of azimuth angle. What is azimuth angle will be explained in this slide, more on this slide. So azimuth angle is, for simply where is facing of the panel itself. So for example, if our panel is facing to the north, and then azimuth is 0, and then to the east, this is the roof, for example. So lambda, in this case, is 90 degree, and then south 180, and then west. So if we see the roof of the house is varies from house to house in the city. In this simulation, we take Jakarta as the object of the studies. So if we see the roof, some of the roof may be facing north, so we call gamma or angle of azimuth is 0 degree. So we make a simulation from 8 different azimuth angle in these studies. So from 0 degree, from 45, and then 19, and then 115 and 118, and we take the simulation, and then we compare the result. So by this study, it's expected that we can compare how much energy different if we have different azimuth of angle for the different system in the rooftop in Jakarta. So again, lambda here is azimuth angle, and beta is the tilted of the roof or tilted of the panel itself, measured from the horizontal. In the simulation, we make beta is 30 degree. So the base of the measurement is 30 degree with variation of azimuth angle. So the method is we do the simulation using software, so-called Solar GIS PP Planner Simulator. It's available online. Everyone can access it by small amount of subscription fee. And how the simulation work, how the software work is based on this algorithm. So I am not going to go deep in this explanation, but basically there is an input and there is output, what we can see from the result of the simulation. So this is the input parameters. Again, we simulate with angle of azimuth edge variation from 0 to 270 degree. So actually one more here, 315 degree. Okay, so yeah, again, till it is 30 degree, and this is the situation, or this is the condition of the simulation. We input the parameters, and as the result, this is the solar energy availability in Jakarta during 1 year. So from January to December, there is variation through the year. And then this is the temperature. If we see, the temperature is always about 26. And then energy per kilowatt hour per square meter during daily of every month is shown in this picture. It is interesting as well that the solar radiation is consisted of diffuse and direct. So component of diffuse can be seen here is larger than direct. That means, yeah, component of diffuse is majority in the component of radiation. So it can be caused by the particulate in the air to make the diffuse radiation in the air in Jakarta. It needs to be further studied for this one. Can be because the city of high pollution and so on, but need study to be done for further conclusion. So there is a variation of energy during the month. The highest is during August, September, October, or during July and to October here, up to higher than 5 kilowatt hour per square meter per day during this month. So this is the potential of solar energy to be exploited, to be extract to get electricity from the PV system. And if we see the daylight, almost 12 hours per day every month, and only some days here during June is less than 12 hours per day. So this is the main result. I think from the simulation, we can compare the result from month to month, and then from angle from 0 to 315 degree. So from facing north, northeast, east, southeast, south, southwest, west, and northwest. So this is the result. If we compare, there is slightly different from roof to roof, that with different azimuth angle. So if we compare from facing north to northwest, it can be seen here. So the highest will be for northeast of facing of the panels, and the lowest is from the south, facing south of the panels. So if we see the difference here, there will be some 100 from the highest to the lowest of energy. Okay, this is the main result from our simulation. And as a conclusion, the variation of azimuth angle result in monthly specific energy output varies from 1,107 kilowatt-hour per kilowatt peak to 1,242 kilowatt-hours per kilowatt peak. The highest specific energy output of rooftop PV system in Jakarta with a fixed tilt angle of 30 degrees will be produced by the angle with azimuth angle of 0 to 45 degrees. That means the system that facing around north or to northeast orientation. However, this would be recommended that the further experimental measurement for validation in this data. So this is the conclusion and recommendation of the research. And this is the end of the slide and the presentation. Again, thank you for your attention.
And this was a part of our research in one of the subjects that we together teach. It's called Menswear Design Project, which during this COVID-19 pandemic, the students were not able to make any physical products, And we had to shift the class task into a digital prototype, and they actually did very well in this. Okay, so I'll just move on to my next slide. All right, so where should I be? Here. Okay. So yeah, the background of this research is actually pretty simple, where COVID-19 pandemic has spread widely across the world, and this results in undeniably significant impact on many aspects, including the fashion industry for sure. And this condition has forced us to do some shiftings to make the industries run smoothly even during these unfortunate timings. For example, there were some major reductions in the fashion production process because of pandemics. We can see that in Bangladesh, in Vietnam, in Indonesia even, yeah, the production process reduced a lot, the productivity. And not only that, us as lecturers, we also experience some difficulties in the learning and teaching process. So yeah, but thank goodness we have this thing called technology, yay, and it allows us to be more productive and to be more connected to each other. All right, so one of these emerging technologies is digital prototyping, which we can see here, like this one in the picture. And I am sure all of you, all of the audiences here are aware of this. And in fashion industries, like any other industries, we also have such technology, although it's not that popular yet in Indonesia. I actually used this in menswear design project, and it was successfully done by the students. So yeah. However, digital prototyping is actually more fancied by designers outside Asia. They use it to communicate the design better with their teams, with their suppliers, with their producers. And good thing about this is it also supports sustainability, because we can actually save materials. Well, even though it's nothing new, the industries in Indonesia have not used it efficiently. And there are many factors to it. One of them is the slow adoption that the people here have towards this innovation. So we think we need to gain more insights from the potential users. And since the digital prototyping is considered as new innovation, yeah, as an emerging innovation, so we need more inputs, we need more insights to create this innovation better. And since the digital prototyping is not too fancied by the people here, we have to gain the user perceptions from function-wise, financial-wise, also the social aspects, the psychological aspects. And we will also present the challenges and opportunities, also with the limitations of the research at the end of our presentations. Yeah, so for the methods and data collection, of course, we did this research qualitatively. We did an online interview. We online interviewed Indonesian users, which we divide into two groups. They are academic users and independent users. So academic users here include lecturers, whereas lecturers and students, actually, sorry. And lecturers majority and students just a little bit. And the independent users include designers and entrepreneurs in fashion industry. So yeah, we picked these people from this background purposely, and we sent them our questions. They answered, and we had follow-up questions for some of them. And these are the outlines of the question we ask. Firstly, it's about demographic section. The second one is the first impression when they see a digital prototype. Also, the third one is the design process. We wanted to compare the design process, the conventional one and the one with the 3D software. And then the benefits and disadvantages of the use of digital prototype and their further expectation to develop the software better. So yeah, okay, I'll move here. We intended to interview a total of 70 participants, but however, the total that responded to us was successfully interviewed was only 61 participants, and that's okay. They are from different backgrounds, from designers, fashion entrepreneurs, lecturers, all in fashion design background. And the academic users participant interviewed were mostly in the age group of 35 to 45 years old, as you can see here. Here, here, and many of them have taught in fashion design major for several years, so totally not a newbie. Meanwhile, the designers and entrepreneurs were mostly in the age group of 17 to 25 years old, which is quite young. So before we actually interviewed them, we presumed that they were familiar with technology. Right, so as we presumed, many of them are familiar with the technology. This is the technology, okay? The software is called Cloud 3D. It's amazing. This is the interface, and we can see that it's a 2D pattern here. This one is the skirt pattern. And amazing thing is they can transform into this one, the 3D one. Well, although many of the interviewees are familiar with this, the 3D technology, the 3D prototypes, not many of them can adapt or even use for design development in fashion classes, for professional use. No. Even for the young designers and entrepreneurs, they have not used the technology. So yeah, we gather all of their answers and we classified them into 4 essential values in innovation as stated by Dillon and McLean. Yeah, functional aspect, financial aspects, social aspect, and psychological aspects. All right, so move on to here. The functional aspects. So in terms of functional value, the many participants stated that 3D garments allow the students to visualize the garment concept better, because software like the Cloud 3D makes it possible to transform the 2D visualization to a very, very realistic 3D model like this. Well, it also have like layering effect for details like this one, it's got pleats, this one ruffles, so very realistic ones, right? And because of this customization, 3D samples can also ease the students in creating drapery, from fabric and experimenting with draping styles very, very easily. And the properties are even editable, so even better. When the students want to make a thicker and denser cotton fabric or even the lighter one, they just have to edit it in fabric properties and voila. Wait, I'll move here. Okay, so this is the fabric properties tool. We can make it thicker or even lighter. So yeah, all of these good things the software provides, it leads to, it leads to effectivity and time efficiency. For sure, it saves time, and we successfully summarized some of their scattered answers about comparison of design development that we talked about before. When they use the technology and when they do not use the technology. So top one is the conventional product design process. As we can see here in the diagram, there are 8 long steps, 1, 2, 3, 4, 5, 6, 7, 8, yeah. 8 long steps from brainstorming concept and final product. However, whereas using this digital prototype, the 2nd to the 5th process can be done digitally, because here material selection, design sketches, pattern making, and sample, you can actually do it here in 2D and 3D design using digital prototype. So it would be very amazing. And it can save time until 50%. So function-wise, it's good. Well, however, there were also cons to this. The contrary, the fabric handle is still questionable because we cannot physically touch the fabric. And surely the fitting process might not be very accurate. The second one is the financial aspects. So continuing the time efficiency that we talked about before. Wait, I'll move a bit here. It was also proven cost efficient and cost effective, because we need less materials, we need less time, and even less people to do this and that, trial and error. And we don't need to experiment and fail like 100 times. because we can actually do the experiment in the digital prototype software. However, for some people, especially the ones in the age group of 45 years old and up, it seems that it's not that efficient because they stated that they need a high spec laptops or computers to run software, and it is expensive, to be honest. For social aspects, so we found various answers to these aspects from those two groups, from academic users or even independent users. They think this digital prototype would ease them in communicating online, and good things, it can enhance their decision making and picking materials, picking shapes and styles when they talk to their designers or their teams. So it can create a better production process. And also, there were some concerns about shifting in roles and objects, jobs. Why did I say objects? In fashion industries, for example, it can push the workers to learn new skills, knowledge, and technology for them to keep up in the digitalization era. Well, although all that, we found that it's accessible to everyone, even though those people, they who has no background in sewing, like me. The last one is psychological aspects. So yeah, this also plays an important role in participants' perceptions. So many of the academic users stated that they feel proud to post their students' virtual prototype work, which is good because they thought it would look professional. And that's a good thing. It also shows that the use of this virtual prototype software can increase their beliefs about their creative competence. And this belief leads to a feeling of ability to finish the goals and all the tasks, all the works, and they have a feeling of persistence to failure. And this is great. For the independent users, they feel the same, and they feel that with digital prototyping, they can create impactful change with innovation ideas. It also eases them to execute their ideas and impress clients. So it has a positive effect on their psychological aspects, like they can increase their self-efficacy of the users. So this diagram was made as the summary of all users' perception towards innovations. And we really hope that this technology can be adapted more to create a better and more sustainable industry. Well, of course, there are rooms for improvements, and we can start by talking about the opportunities that we have here. Well, this digital prototyping, it's good. Yeah, so it can be a way to move a more digitalized, higher, an advanced level of industry. And there are also some suggestions for this software, for this technology, which is maybe in the future, it can be integrated with fabric suppliers all around the world. So it would help the users to visualize the drape better, because every fabric from different suppliers has different characteristics. For example, kain katun from Pasar Atom, each store, it would be different. So maybe it's the thick density, or I don't know, the handle would be different. So if the big textile suppliers, they have their fabric properties and characteristics precisely recorded in 3D data, of course, the digital prototyping process, the digital draping process in the software can be done very, very easily and accurately. And the challenges here would be the slow adoption of the people to accept this innovation. That's why we have to keep digging and digging and digging more to make it adaptable and accessible for everyone in the industry, and also the cost for the system and the hardware to run the software, especially for small scale designers. So it has to be paid attention. So this is my final slide. For limitations and future research, so the limitations of the study was the sample, who are limited to the academic and independent users only. Whereas there is another important part in this, which is the consumers. Well, independent users' perceptions might be influenced by their consumers' opinions about the use of digital prototyping to represent their product, whether it could be used for marketing or to communicate with the consumers better. So that's why the future research may need to be conducted to see from the consumer's point of view to validate the findings of this research. All right, so that's all from us. Thank you for listening. Thank you for paying attention. Goodbye.